So here is a list of frequently made mistakes that I've seen from assignment 1A. So far, there's a couple reasons why you should pay close attention to this video, which will go up on the website right after class. Number one, it'll help you hopefully avoid these mistakes in the solution that you're doing so that we won't even have to deal with them at all when I review your code because you will have already fixed the mistakes. And secondly, these kinds of things have a way of finding themselves onto the quiz. So be aware of what the mistakes are and of course, more importantly, how to fix them. First and foremost, please don't remove the to-do tags when you add your solutions because otherwise it's hard for me to find where you've made the changes in your code. I just go into your files and search for the at symbols or the to-do symbols and so on. And if you remove them, then it's hard to find them. So make sure that you don't remove those. Also, please make sure that you comment your code consistently if/when you add code, which you should be doing to the skeletons. Make sure that you explain what you're doing. You don't have to write a book, but just give me a brief explanation, roughly with the same level of detail as the comments that I have as well. And also, please don't remove my comments because that makes things confusing too. Resist the urge to add other methods or other classes to your solution. But if there's some reason you really feel that you must do that for some reason, make sure you document your code. So once again, part of the goal here is just to learn to do good coding habits. So let's take a look at some of the things that you shouldn't do. So one thing to do is there's a factory method that's called simple being runnable. And I think it has like a being factory or something like that here. And let's see. Oh, sorry. This was the solution that the code was like. And this particular implementation is way too complicated. The actual solution here is absolutely drop dead simple. It's one name. It's a very straightforward name. And the best way to figure out what the name should be is to take a look at the type that's expected for the parameter to the simple being runnable constructor, and then to go ahead and take a careful look at what the runnable threads manager class inherits from, and just think carefully about those things, and that will give you some hints about what to do. It's really, really simple. If you find yourself doing anything the least bit complicated, you're probably overthinking the solution. But it's also part of the assignment to figure out how to do, so you have to spend some time thinking about it. Okay, let's now move down into some of the methods that make up the runnable threads manager.java file. So one of them is run simulation, and the comments indicate that there's 3 things you have to do there. The first thing you're going to have to do is basically begin being threads, which we'll talk about in a second. The next thing you do is you need to create and start the waiter for being threads. And this particular code here was just doing some weird things. You don't need to be creating a thread here. It's just confused. So don't do that. You don't need a thread. You'll have too many levels of threads. And then when you do call the create and start waiter for being threads method, you need to make sure you take a careful look at the return value it has, and you need to store that return value somewhere in a local variable so that you can then use that return variable in order to be able to wait for or join to wait for the computations to finish. So again, just some things to be aware of. It's very straightforward, but you have to make sure you get all the pieces right. Here's the begin being threads method. This particular implementation is got way too much stuff in it it doesn't need, and then it's missing some stuff it does need. So in particular, you don't need to use the synchronized keyword. There's no reason to synchronize. There's no race conditions going on. We're not having begin being threads called from multiple threads. So there's no issues of corruption or potential for corruption of the data. Make sure that if you're doing the grad student version of the assignment, you set the uncaught exception handler. Actually, quite honestly, it's not a bad thing for the undergrad version to do that too. It's not required, but recommended if you can figure out how to do it. It's pretty straightforward. You want to make sure you do that because if a thread were to exit, then if you have the uncaught exception handler, and the thread exits because of an exception, you'll find out that why that happened, or that you'll find out that it happened, which can save you a lot of headache when you're trying to debug your code. Another subtle issue here, make sure that you initialize the mBeing threads list before you start trying to make method calls to add threads to the list. Otherwise, chaos and insanity will result, namely in the form of the null pointer exception that you'll get. So that's something you always have to remember to do if you're programming with kind of classic object-oriented Java. If you happen to know something about modern Java, like Java streams, you can use a Java stream here, and it's much cleaner. So those of you who took my CS 253 class last semester, strongly recommend you try to use a Java stream. It's a lot cleaner and less error-prone. Some other things to do, and again, I realize that not all of you had the luxury of taking my other course on functional programming. So if you don't feel like you know how to do this, it's okay. But you should try to get in the habit of using modern Java features like the for each method instead of the for each loop, and also doing things like using method references instead of doing function calls and method calls. So if you feel comfortable doing that, strongly recommend it. It'll make your code so much cleaner and neater, but it's not required. Also, this particular piece of code does not require a try-catch block. So there's no need to wrap the call to being thread.start in try-catch, because we're not worried about an exception that's being thrown there. Here's some other things from begin being threads that could be improved. This code isn't necessarily wrong. It just could be improved. So whoever wrote this code obviously knew something about Java streams and was trying to be clever by saying mBeing threads, which is a list, .stream, which would make a stream, .for each, which is a terminal operation on Java stream. But it turns out that there's already a for each method on list. So there's no need to call for stream to turn the list into a stream before calling for each. You can just call for each directly on the list. So that's a little cleaner. Likewise, the begin thread arrow begin thread.start, that's a Lambda expression that can be simplified magically by using your compiler, your IDE, or your Android Studio IDE. It'll automatically convert that into a method reference instead of a Lambda expression. So if you hover your mouse over there and click on the options that it prompts you for, which are usually like this little orange teardrop shaped icon, that'll go ahead and convert it to a method reference. So it's good habit to get into using method references instead of Lambda expressions whenever possible. Here's an implementation of create and start waiter for being threads that just doesn't do anything sensical. It's nonsensical. So you need to actually implement what's described in the comments. Here's some other things that you have to be very careful about. We're going to talk about this in a second when we talk more about threads, but always be aware when you make a new thread, like we're doing here, that you need to give it some code to run. Now, we're going to talk a lot more about that in a second, but that's important to remember. When you make a new thread, you have to give the thread some code to run. And there's various ways to do that, but this code doesn't do any of those. So we're just making a thread, and it's not ever going to do anything when we start it. So don't do that. Make sure you give it code to run. And then down here, this code is confused at multiple levels, but generally it's a good idea to avoid index-based for loops and instead prefer either for each loops or the for each method or something else altogether, like a stream, but don't worry about that now. So don't use the index-based for loops. Use a for each loop or a for each method. And also, you don't have to call any of this stuff here. That's handled for you by the framework. It handles all the gazing and calling and so on. And then here's a subtle problem. For the create and start waiter for being threads method, you're creating a thread internally, and then what you want to do is return that thread reference as the return value from that method. This is returning the current thread, which is not the same thing as the thread that you just created. It'll really be the caller thread, which is not the thread you want to return. That would cause a lot of confusion. Here's some other implementation issues with create and start waiter for being threads. Please get in the habit of using a Lambda expression instead of an anonymous inner class. It's, again, if you really can't make sense of that, you're welcome to use an anonymous inner class, but it's good habit to get into using a Lambda expression. It's a lot more concise. It'll save you from the evils of carpal tunnel syndrome. And you won't have to type new runnable open close, open curly brace, at override, public void run, open close, open curly brace. You just have to write the code, which is much more concise. Some other things here. Again, you don't need to use mbeingthreads.stream.forEach. You can just say mbeingthreads.forEach. There's no need to create an extra waiter thread here. Instead, all you need to do is write code that will join with all the threads when they're done. So you just have to do the barrier synchronization join. And I recommend you do it from a for each method, although you can use a for each loop too if you really want to, but you don't need to make an extra thread there. Now let's turn our attention to the simple being runnable class that really has only one method called acquire Palantir and gaze. And the purpose of that, as you might expect from the name, is to gaze into the Palantir. And there's a bunch of problems here that a lot of people run into. So one problem is make sure that you check the return value of acquire Palantir to see if it was null or not. If it's null, then obviously you want to print an error message, a meaningful error message, and then return. If it's non-null, then you want to have a try catch block that will gaze in the try portion, and then, sorry, not try catch, try finally. You want a try finally block, and you want the finally part of the try finally block to release the Palantir. And that way, if the gaze method were to throw an exception, you wouldn't leak a Palantir. It would always be automatically released. So you got to make sure you do that. Here's a piece of code that attempts to do this, but it's got a bunch of problems. Problem number one is you need to give a meaningful error message. Don't just say error and just have an empty string. That doesn't give you anything useful. You have to explain, failed to acquire a Palantir or something like that. The other problem here is that we have a try finally block, but it's not really organized correctly. And in particular, notice we check to see if the Palantir is null. That's good. And we only gaze if it's not null, and that's good. However, down here, we're always releasing the Palantir, even if it's null. And we do not want to be releasing the Palantir for a null. We don't want to be releasing a null Palantir. So we don't want to always release everything every time. You only want to release it if you got one that's valid. So these are some of the things I've seen so far. Hopefully this will be helpful for you to avoid when you do your code. So make sure you go back and watch this video carefully. When you write your code, please try to avoid these mistakes because you've already been given some feedback in a generalized way. Of course, I will still review your code and give you feedback on what you've done, but this will probably save you some time and think carefully about why these mistakes are mistakes. Because number one, as I mentioned before, it'll be good to you to write better code from the start. And number two, it'll be able to prepare you for the upcoming quiz.